these 2 lights come on, and then around mid-morning, then we have 4 lights come on. Now we have all of our lights coming on, indicating full sunlight, and then eventually the time will pass and our sun will set, kind of really tricking the plants into thinking that they are in outside. So this system is 100% self-contained. It runs 24 hours a day. The cycle runs for 77 seconds every 1800 seconds right now, but that's all adjustable via the controller. So that's kind of a background on this one. This one was really the proof of, well, we have this idea, can we do it? The evolution of this project kind of came through following the engineering design process, right? So we had this idea, could we make a completely automated system that produces food without human interaction? We researched the aquaponics. Yeah, I think it can. I personally have the skills to make all of this, all of the electronics work together. And then we built it, and then there was some design flaws that we noticed and some things that we wanted to improve on. So that led us over here to Aquaponics 2.0 or Aqua 2.0. And this is our kind of our latest and greatest system. Right there we have fish cam. So let me, it's on night vision right now because it's down in the water, but let me change it over for you to check out. So I'm going to just change it over to daytime it's a light sensitive camera, so it should be switching over there. But this, all of the components of what we're doing here are different components that we teach the students in our classes. So hopefully that'll change over. Did you see it come up out of the water?
Yeah.
Maybe didn't see the light on it. Oh, if it doesn't work, it doesn't work.
Oh, it's color now.
Yeah, so yep, that's what I wanted. I wanted
Oh,
it to
okay.
jump back over. So that was infrared camera for us to be able to see in there when it's dark. Yep, there it went. So now we dropped it back in there. Now this will actually be piped out to our website, and I'll be able to jump on our website anywhere in the world and see my fish swimming around. So there's one. They come right up to the camera and pick the algae off. So yeah, and then the design idea on this one was we wanted to try to simulate a size large enough to be able to sustain like about a family size amount of folks. So that was our goal with the original development of this one, was to make it larger than that one and utilize a little bit bigger fish tank. So we had the possibility of growing some larger fish and starting to incorporate the fish food fish as food into the system. So this one does operate a little bit differently than that. We still are pulling the waste out. Waste in the water out from the bottom. Here, you got to get a picture of the fish eating. Let me bring them up. Come up and eat. There's a combination of koi and goldfish in there, and there's about 50 of them.
Oh, okay.
Yeah, when I got them, they were about this big.
So I guess goldfish are considered extinct now. What they were saying.
Well, news to me. Maybe extinct in the wild, but they're definitely been,
there's plenty in here,
yeah,
huh?
They're definitely kept alive in pet stores around the world. So we went with this species of fish because ours are we're not really growing ours for consumption. Ours are more just pets, honestly, and that's the reason why that's the only part of my process that isn't automated right now is the fish food, just because I get the joy of coming in here to feed my fish in the morning. But the process is very much the same. This one we added some extra design. Obviously the lights are a lot better wavelength. We have a filter incorporated. We had to do a little bit different plumbing than we did over there just because of the larger system. Those sumps bring the water back up into our main tank from going through its process. Our ultimate goal with these and the continued evolution of our control system is we want to be able to set these up in remote places throughout the world and have these things be able to control themselves, and the next version, the next generation of this project, we're going to have continuous water monitoring for fish health and environmental parameters that are optimal for our plants. So what we plan to do is, with our control system, we have the ability to set up trends, and the trend would be something along the lines of, for example, just dissolved oxygen. For fish health, we want to make sure that the oxygen is at the right level all the time. So how that will work is there'll be a sensor inside of our water checking dissolved oxygen all the time, developing trends with our control system. And then part of what we will do is we will program in a high and a low mark that we will be able to then, once those the sensor recognizes that those parameters are outside of normal, it will either it will send us a text message on our phone to let us know that there's an issue. And then the other thing that we'll do is it will self-heal. So in a dissolved oxygen situation, what would likely be the solution to that is to just cycle the pump to re-agitate the surface water and to force some dissolved oxygen back down into the water. So that'd just be one example. But the goal is to have these energy neutral, and that's the reason for the new lights too. Those are both LED lights that drive our continuous consumption down. And the other thing that we did that with both of them in order to keep energy neutral is how we set the cycle up. So these are based on what's called a flood and drain aquaponics system, to where you fill up a tank, you get the roots wet and the bacteria wet, and then you drain the water back out. Well, that's the general idea, but the problem with that is a traditional flood and drain is that your pump has to be running all the time. Well, we've designed this system to eliminate the necessity for that continuous water movement by how we have it set up in the design that we have, to where all we have to account for, if we're trying to take this thing to energy neutral, is the peaks and the valleys of the current consumption that we take off of the pump. And there's some different design ideas that we have to minimize that current too. Our next step is going to be, obviously, we're going to get these on renewables. We have solar panels that we're going to be experimenting on here very soon. Probably this semester we'll be getting the solar panels out and to see if we can run this version on there. And we're also having a design competition for our students to design the next version of this, which we're going to do a big presentation on Earth Day with Rapid City Sustainability Committee and Dakota Rural Action. So looking forward, lots of really exciting stuff coming down the pipe for this. So
are you going to have something at the fairgrounds with the?
Yep.
Okay.
Yep. Dr. Murray and I are gonna do a presentation about our work and the sustainability efforts that we're producing here at Western Dakota Tech, and we'll talk a little bit about we also won the National Science Foundation Community College Innovation Challenge off of this project.
Mm-hmm.
Talk a little bit about the opportunities that we had over that. Talk about just how many folks are looking toward what we're doing as the future of food insecurity and food desert solutions. So this also is a pretty big deal, and I like to direct everybody to this whenever we do a presentation. So this is our motivation right here. All of these red dots represent homes inside of the Rapid City city proper that are using local food banks, and then all of the yellow dots are the folks that aren't necessarily in the official city but are still using those food banks, and there's a total of about 9,000 just in Rapid City. And then the other thing that we always talk about too is how food deserts affect those folks. So this other map we have underneath it here, this is a layout of all of the different food deserts that we have in Rapid City, and you see a lot of continuity between the hungry homes and then the food deserts. Mm-hmm. So this is part of our solution. Like, our solution is to build, as we develop our project here at Western Dakota Tech, we hope our next level to be community level testing, to where we can actually provide scientific data to be able to support the theories that we're making on whether or not this is an economical way to produce food. And the work that we're going to do with the OLC is definitely going to help prove our theories on whether or not we can make these viable. So this system right here has been in operation since probably mid-September. That one over there, this is the second year that it's been operating, and we've harvested all kinds of, like the list goes on and on and on. This one right here has peppers, pumpkins, purple green beans, tomatoes, 2 species of peppers, strawberries, lettuce. Lettuce grows really great in these things. What else? There's different herbs in there. There's oregano, lavender. There's some acorn squash. I mean, this year was kind of an experimental year to see what plants and crops would really grow good in here. This one over there has citrus trees. It has dwarf citrus trees. There's a lemon, a lime, a tangerine, and orange, and then parsley, chives, basil. That tree in the back, there's a basil tree. This right here is basil. We went, since this is our smaller setup, we really went after herbs because you can get a lot of them in a small space, and they're pretty powerful. They pack a punch, and you can get a lot of good. So this guy just kind of got harvested here a couple days ago. But yeah, we've had several rotations of crops through. But one thing that I'm really excited about on this one is that I bought purple green beans when I started, and we planted them, and they vined up on the outside there and did exactly what I wanted them to do. But what was really cool is we actually ended up having kind of a surplus of them. We produced more than we consumed. So I took some of them, this one right here in particular, and what a great thing to put on video. This guy right here is a 2nd generation purple green bean. So a lot of times when you get these weird plants, they're hybrids, and you can't plant their offspring or their seeds. Well, this one I was able to plant, and there's 3 of them out here that are producing fruit off of the 2nd generation of their planting. So these are seeds of the seeds that I grew. So pretty excited about those. This is squash. There's more lettuce in there. Here's some of the herb stuff. We're getting a lot of shade from these big leaves in here. We'll have to adjust that next year to allow the smaller stuff. We're probably going to stick to a monocrop on this year. Maybe use just the sections of the grow beds for one crop instead of putting this whole menagerie of different crops in here. But like I said, it was an experimental year. This one's pretty cool. This is a pumpkin, a giant pumpkin. Its root base, I think that is its root right there, right here. And I think it goes, I think that's the root base, and that's the end of it up there.
Oh,
So
wow.
it's growing over toward this heater here. We just have radiant heat, so it's making its way over to that radiant heat. Yeah, that right there. Not only is this a pumpkin, but it's a giant pumpkin. So eventually, that little bulb right there is going to be a giant pumpkin. So we're going to have to build a net or build some sort of a blocking to be able to.
It's gonna be full of plants up in here.
Yeah. That's the other really neat thing is this whole project was designed to be able to teach electrical students process control, right? The cyclical nature of needing to have this stuff go through its cycle, it lends itself beautifully to be able to apply, industrial control work, the thing that our students need to know. So I'm teaching them that. I'm also teaching them how to network with cameras. All of the electrical things that are being taught here, it's like super important for that. But on top of that, these students are also learning about plants, plant growth. They're also learning about how to maintain fish. Like we have koi in here, but there's no reason we couldn't have an edible species in here. Like I said, we have koi just because they're my pets and I like to look at them every day. But that's the ultimate goal of aquaponics, is to produce protein by way of fish and vegetables, and be able to try to sustain yourself with a small footprint and minimal energy consumption. So we're on the way. We're definitely on the leading edge of this concept of kind of human-free growing. There's some of the students at the School of Mines are working on like robotic harvesting and then weed removal. I think that's great. What's unique about ours is there's no weeds. Like this is a controlled environment, so we have the ability to eliminate that from the get-go just from what we introduced into the system. So yeah, lots of fun. I sit out here and just watch my fish swim a lot of times. It's really peaceful. Who doesn't love a koi pond, right?
Yeah, I went over to Jelly Lane Floral. They got a pond over there, and I thought I thought they were doing aquaponics, and then they have like the moss underneath. So I thought that was green algae, and I thought they had a system like that going, but they
Yeah.
no.
Yeah, we have some
I mean,
green
that's
algae.
too bad because they really, I mean,
They could.
could do it so
Yep.
easy, you know,
Yep.
but
Yep. Yeah, we have green algae going in here. It's more of a hazard right now. So Dr. Murray does, so she's the head of our environmental engineering technician program, and her group does a lot of the water monitoring that we have right now. And that is actually the missing piece of my research is, I'm more of the engineering side of things and designing this to meet the parameters that I'm after. And the side that she brings to the table is we want to maximize the
is it the pH of the water?
all of the
and the temperature, all of that stuff?
Yep. So pH is a big one. It doesn't fluctuate a lot. Nitrates, the nutrients in the water, if the plant root system that we have isn't absorbing enough of the nutrients from the bacteria conversion that we have, then that returns back to our fish tank. And although it's not as toxic as the ammonia for the fish, it can lead to problems in the water just due to algal blooms. If the algae blooms, it will displace all of the oxygen that the fish need, and yeah, it's just not a good thing. And that's what her and her team do for us. They are developing all of the right parameters. We're in the process of determining the beneficial bacteria that we need to have. Dr. Marie is a microbiologist, so that's kind of her deal, is she's looking at the beneficial bacteria that we need to have to be able to convert all of the maximum amount of fish waste into nitrates to be able to produce the highest amount of fish and plants using the lowest amount of resources via the utilities, etc. So yeah, I do a lot of talking. Do you have any questions?
No. I awesome.